Hello everyone, welcome to your final honors chemistry lecture of the year. So today we're going to talk about calculating the oxidation states of elements in more complex molecules and do a little bit of review from the notes that you got earlier this week. So when I say oxidation state, what I'm really thinking about is essentially what is the charge of the element in the molecule. And you'll hopefully see that this is a pretty familiar skill that you have because we've been secretly doing it all year. I mean, maybe not secretly. So we're trying to calculate basically the charges of elements in molecules. And when we do that, we can figure out whether or not that element was oxidized or reduced. So first, we need to come up with our important rules. And they're listed in order of importance. So the most important rule is that we assume that the oxidation state for hydrogen is always +1. And there pretty much isn't going to be any exceptions to that rule in honors chemistry or AP chemistry. The next rule is oxygen. Oxygen has an oxidation state of -2. The only time that there's an exception to that is when you have hydrogen peroxide, which means that oxidation state of oxygen is -1. But that's just one specific exception. You do need to know that exception, but that's the only one. Also, when I say oxidation state, I could also be saying oxidation number. They're essentially interchangeable, for me anyway. Okay, so we have our rules. We have the one exception to those rules, which really isn't that big of a deal. And then the next thing you have to know is that you just follow the normal periodic table groups common charges. And you've already memorized all those. Group 1A plus 1, group 2A plus 2, right? However, what you do need to note is that there are lots of exceptions to those rules, which means that often nitrogen is not going to be -3. Could be +3, could be whatever. The most important rules, the ones that you definitely need to focus on, are rules 1 and 2. Okay, so let's do some examples. So the first one's easy. It is an ionic compound because we have a metal and a non-metal. We know that lithium, where it's at in the periodic table, has a +1 charge, and chloride has a -1 charge. Here we just assume that these are the normal charges because this is how we just deal with ionic compounds. And it's neutral, so that all works out. For example 2, we have a little bit more complicated ionic compound. We know that OH, though, we have our rules for them, but OH as a group in a polyatomic sense is called hydroxide, and it has a -1 charge. So there are 3 of those, and then we want to figure out essentially what is iron's oxidation state. And since we don't know it yet, we could put it as an X, and all of these things need to add up to what? 0, right? So we're trying to figure out iron's oxidation state. Okay? Now, this may look familiar to you because this is how you would have calculated what is the charge on iron. It's the same thing. How would you figure out how to name this? Is it iron 3? Is it iron 6? Whatever, right? You would have to figure out its charge. So, X minus 3 equals 0. X equals +3. So oxidation state of iron, then, is +3. You just had to set up a simple little calculation. We set them all equal to 0 because the charge on this molecule is 0, right? It's a neutral ionic compound here. Well, let's do one where the charge is not 0, where it is not neutral. So here, right, we have chlorine and oxygen. So let's find chlorine's oxidation state. And you're like, well, how do we figure out what things are, right? Well, according to our rules up here, we know that oxygen has a -2 oxidation state. No rules about chlorine, really, and no rules about anything other than hydrogen and oxygen, right? Those are the ones that we always know. Everything else is pretty much up for grabs, could be anything. So, oxygen's -2, we have 4 of those, so 4 times -2 plus, well, we want to know what chlorine is, but we don't know what it is yet, so that's an X. And all that needs to add up to equal -1, right? So -8 plus X equals -1, X equals +7. So here, The oxidation state of chlorine is positive 7. Now, if you're wondering how we knew what oxygen was, again, we have our two rules. Oxygen and hydrogen are pretty much always going to be +1 and -2. All the other non-metals in the periodic table can essentially be anything, right? It just depends. Always make the assumption first that oxygen and hydrogen have these states and then solve for everything else. So let's do nitric acid. So we know hydrogen is +1. We don't know what nitrogen is, and we know that oxygen is -2. So we have hydrogen and oxygen, and we just know those because that's just part of the rules. All of this has to add up to equal 0. So we have -6 + 1 is x - 5 = 0, x equals +5. So the oxidation state of nitrogen is +5. You're like, well, what's the oxidation state of hydrogen? Well, it's +1. And how do we know? Because of the rules. The rules are important. Okay, let's do this permanganate anion. So we don't know manganese, so we call it X. We have 4 oxygens, and we know that oxygen has a -2 oxidation state. All of this has to add up to equal what, though? Is it 0? No. It's -1, because the charge on the whole molecule here is -1, just like it was in example 3. So x minus 8 equals -1, x equals +7. That's for manganese. Okay. Carbon dioxide, binary molecular compound, 2 nonmetals. So we don't know what carbon is. You're like, how do we not know what carbon is? Well, we don't really have any rules for it, right? The main rules, the rules that we follow, are Rule 1 and Rule 2. Rule 3 is basically just saying, if it's not oxygen or hydrogen, it could be anything maybe, right? You just have to check. So, we have 2 oxygens. We know that oxygen has a -2 oxidation state. All of this has to add up to equal 0 because the charge of CO2 is 0. X minus 4 equals 0. X equals +4. That is for carbon. Let's do sulfuric acid. So we have 2 hydrogens at a +1. We don't know what sulfur is. We have 4 oxygens at a -2. All this equals 0. So we have +2 plus x minus 8 equals 0. X minus 6 equals 0. X equals +6. Right? That is for sulfur. The last one, we have oxalate anion. So we have 2 carbons, 2 unknowns. We don't know what it is. Plus 4 oxygens, which have a -2 charge. All this has to add up to equal what? -2. So we have 2x minus 8 equals -2. 2x equals +6. X equals +3. And that is for a single carbon in oxalate. So hopefully through those examples you were able to refresh yourself on up here, right? Doing those calculations like we used to do to find the charge of something. But now what we're saying is that's the oxidation state. Okay? So oxidation versus reduction. So we know that oxidation is about losing electrons and reduction is about gaining electrons. And we have this fun mnemonic, oil rig. Oxidation is losing electrons, reduction is gaining electrons. So how do we know if something was oxidized? Well, if oxidation occurs, that means that the oxidation state, which is all those things we just calculated, or the oxidation number, it increases and it becomes more positive, which implies that we lost electrons, right? So as an example, if we start with perchloric acid and we go to hypochlorous acid and we go to perchloric acid, if we calculate the oxidation state of chlorine here, you'll find that it's +1. If you calculate the oxidation state of chlorine here, you'll see that it's +7. So what we know is that chlorine was oxidized and it lost 6 electrons, right? It went from +1 to +7. We know electrons have a -1 charge. The more electrons you take away, the more positive the ion becomes. So that means that it lost 6 electrons. Reduction is when the oxidation state or oxidation number decreases and becomes more negative, which means that you're gaining electrons, right? Electrons have a charge of -1. If you add more of those negative charges, the whole thing becomes more negative, decreases in positivity. So here we have carbon dioxide going to carbon monoxide. If you calculate the oxidation state of carbon here versus carbon here, you'll see that it goes from +4 to +2. So the oxidation number decreased and became more negative, right? On the number line, became more negative. So that means that carbon was reduced and gained. How many electrons would you need to gain to go from a +4 to a +2? You would need to gain 2 electrons. So when you say something's oxidized or reduced, right, you're talking about a single element, right? Here, chlorine was oxidized. Here, carbon was reduced.